Now let's look at some examples of how to graph quadratic functions. The basic steps are to find and plot the y-intercept and the x-intercepts, if there are any. Then we'll find and plot the vertex and sketch the axis of symmetry. And finally, we can obtain additional points on the parabola by choosing some arguments, x-coordinates, and calculating the corresponding values of the function, the y-coordinates. We can also reflect points over the axis of symmetry because of the symmetrical nature of the parabola. Let's draw the graph of y equals -1/2 x squared plus 2. First, in order to find the y-intercept, we simply let x equal 0, which eliminates the first term of our equation. So our y-intercept is the point 0, 2. We'll plot that on our coordinate plane and label it. And then to find the x-intercepts, we would let y equal 0 and solve the quadratic equation. 0 equals -1/2 x squared plus 2. We can use the principle of square roots, subtract 2 from both sides, and then multiply by -2 to eliminate the fraction. And we have 4 equals x squared. Therefore, x is positive or -2, and our x-intercepts are the points -2, 0, and 2, 0. Put those on our coordinate plane as well. Now we're beginning to get an idea of the shape of our graph. The parabola clearly opens downward, but in order to obtain some more information about the graph, it would be helpful to identify the vertex of our parabola. In this case, we can see that since the x-intercepts are at -2 and +2, the axis of symmetry, remember, must be exactly midway between those 2 points. So the y-axis is our axis of symmetry. This means the point 0, 2, which was the y-intercept, also happens to be the vertex of our parabola as well. So now we're up to step 4, and in order to obtain some more points and draw the graph, we will choose an argument for x. For example, if we choose x to be 4, then we have the equation y equals -1/2 times 4 squared, which is 16, plus 2, or y equals -8 plus 2. So when x is 4, y is -6. The point 4, -6 is on the parabola. Rather than choosing another different value for x, we can obtain another point by simply reflecting the point 4, -6 across the axis of symmetry, which remember was the y-axis. So the point -4, -6 must also be on the graph because it's equidistant from the axis of symmetry. Now we have enough points where we can come up with a pretty good sketch of what our parabola looks like. And we can draw our parabola with the x-intercepts, the y-intercept, and the vertex all labeled. Let's do one more example. We'll graph the equation y equals x squared plus 4x minus 3. Again, the y-intercept is easy to identify because if x is 0, the first 2 terms are also 0. So the y-intercept is 0, -3. And the x-intercepts would be found by solving the equation 0 equals x squared plus 4x minus 3. Now that trinomial on the right-hand side cannot be factored, so we will need to solve the quadratic equation by another means. Let's use the quadratic formula. So x equals -b, -4, plus or minus the square root of b squared, that's 16, minus 4 times a times c. Since a is 1 and c is -3, that means 4ac is -12. All of that is divided by 2a, which is 2 times 1. Simplifying a bit, we have -4 plus or minus the square root of 28 over 2, which is equivalent to -4 plus or minus 2 times the square root of 7 over 2. And then finally, simplifying using the distributive property, we have negative 2 plus or minus the square root of 7 for our x values. In order to get an idea of approximately where these values are, since they're irrational numbers, we can approximate the square root of 7 as a decimal and do some calculations to see that the x-intercepts of our parabola are the points 0.6460 and negative 4.6460. So we will plot those x-intercepts, or their approximate locations, on the graph. Our positive x-intercept is negative 2 plus the square root of 7, 0. And then our negative x-intercept is negative 2 minus the square root of 7, 0. Okay, we're getting close to our shape of our parabola. It looks like it opens upward, but we still haven't identified the vertex. Remember that the formulas we learned for the x and y coordinates of the vertex can be applied to any parabola. So the x coordinate of our vertex is negative b over 2a. In this case, that gives the result negative 4 over 2, or negative 2 for the x coordinate of our vertex. For the y coordinate, we use the formula 4ac minus b squared all over 4a. 4ac is negative 12 minus 16 all over 4, or negative 28 over 4, or negative 7. So the vertex of our parabola is the point negative 2, negative 7. We can plot that on our graph. Notice that that point also is midway between our two x-intercepts, as expected. And the axis of symmetry for this parabola then must pass through the vertex, and that's the line, the vertical line, x equals 2. To complete the graph, we can find some more points. One way to do that is to reflect the y-intercept over the axis of symmetry. So the point negative 4, negative 3 is on the parabola since it's equidistant from the axis of symmetry. And if we wanted to find a couple more points, again, we could choose an argument for x and calculate y. For example, if x equals 1, then the equation y equals x squared plus 4x minus 3 gives y equals 2. So the point 1, 2 is on the parabola. And then again, we can reflect a point to find a point on the other side of the axis of symmetry. And that corresponding point would be the point negative 5, 2. Now we have enough information to make a good sketch of the graph of our parabola. With all the important points labeled on the graph.